Let's wait for a couple of minutes. After that, I will start the session. Hello, please let me know if I am audible or not. Hello, please let me know if I am audible or not. I believe I am audible. Let's wait for a couple of minutes. After that, I will start. Let's wait for some more participants. So I believe we may start now. So this is our seventh NPTEL live session. In the last session, we discussed about pile foundations. We'll solve some problems uh, regarding bearing capacities, pile load capacities of piles. In today's session, I'm also going to discuss about pile foundation. I'm going to solve some problems. And please let me know if you face any doubts regarding the problems that I will solve today. And you may also post your doubts in the discussion forum of NPTEL, and or you may also mail me personally if you have any doubt. And the recording of this session, of today's session, and all the previous sessions, the recordings of all the previous sessions are available on YouTube and also on NPTEL website. And the recording of today's session will also be shared with you guys, and you may refer to these videos later. So let's get started. Let me introduce myself once again. My name is sinjandebnath. I am a PhD student in the Department of Civil Engineering at IIT Kharagpur. And so let's get started. I'm sharing my screen. Please let me know if you can see my screen or not. Hello, can you see my screen? Can you see the slides that I'm sharing? Hello, I can't hear you actually. Please write in the chat box if I'm audible or not. Please write in the chat box if I'm audible or not, and if you can see the slides. Sorry, I can't. I'm not able to hear you properly. Please write in the chat box. Hello, am I audible? Please write in the chat box. Hello. Okay. Thank you for responding. I may start. Okay. Okay. Thank you. So let me just mm, go through the concepts that I did discussed in the last session. Let me just refresh your memory. So actually, so pile load carrying capacity of the pile, or the ultimate load that the pile can carry. What is it? So the ultimate load a pile can carry is equal to the end bearing resistance and also the skin friction resistance. Okay, this way, this I discussed in the last class. I solved some problem regarding this concept. So based upon this concept, so what is QPU? It is the end bearing resistance, and QF is the skin friction resistance. This QPU is equal to unit end bearing resistance and multiplied by the area of cross section area of cross sectional area of the base of the pile, because the end bearing acts as the at the base of the pile, and this one, and QF is the total skin friction resistance, which is Fs. Small fs means the unit skin friction resistance, which is acting along the length of the pile, along the surface of the pile, and multiplied by As. What was As? As is the surface area of the pile. Okay. So for cohesive soil, so for cohesive soil, this Fs is equal to alpha into C dash. Alpha is the adhesion factor, and C dash is the cohesion of soil along the length of the pile. Okay, cohesion of the soil, which is of cohesion of the layer along the length of the pile. Suppose uh, this is your pile, this one is a layer, and this one is a layer 2. Suppose this is the layer 1, this is layer 2, and this is cohesions, and this cohesion is this cohesion of this cell along the length of the pile. Okay, this one is Fs. And what is QPU? QP is the unit end bearing resistance. It is Cp and C. This one is C dash, and the cohesion of the second layer is the Cp, which is associated with the unit end bearing resistance. Okay, and this Cp is associated with the unit end bearing resistance, Cp and C. This Cp, this cohesion is this cohesion of the second layer. Okay, because this pile, the base of the pile is resting on top of the second layer. Okay, so this is it, and this Nc is equal to 9. So 9 Cp it is. So Qpu is equal to 9 into Cp. And this is for the cohesionless cohesive soil. And for cohesionless soil, Fs, that is the unit skin friction resistance, is equal to K into sigma Av dash tan delta. I discussed all this in the last class. Okay, and QPU, this is the unit end bearing resistance. This one is sigma dash NQ. NQ is the bearing capacity factor. Okay, and this one is should be always less than 11,000 kPa. Okay, so this is it. Now we may move to the first question. So what is the first question? So the first question is a concrete pile of 40 centimeter diameter. So see, the diagram is given over here. A concrete pile of 40 centimeter diameter. So the diameter is 40 centimeter. Let me write down all the information that are given over here. 40 centimeter is the diameter, is driven into a homogeneous mass of cohesionless soil. The pile carries a safe load of 650 kilonewton. A static cone penetration test conducted at the site indicates an average value of QC 40 kg per centimeter squared. This one. along the pile, that is QC is along the length of the pile, and 120 kg per centimeter square below the pile tip. That means over here the value of QC is 120 kg per centimeter square over here, and value of QC along the length of the pile is 40 kg per centimeter square. Compute the length of the pile with factor of safety 2.5. Okay, so we have been asked to find out the factor of we have been asked to find out the length of the pile. Okay, so uh, so this one is the cone tip resistance, right? So QP, and actually what is happening is that here cone tip resistance are given. Okay, the resistance static cone penetration test was conducted, and the cone penetration test, and from the cone penetration test we get mm, the cone tip resistance. So here the value of cone tip resistance is given. So QC is the cone tip resistance along the length of the pile, and QB is the cone tip resistance. This QB, this QC is the cone tip resistance is at the pile tip, below the pile tip. Okay, so let me just write it down over here. So QB or QPU, that is the sorry, mhm, that is QB, that QPU. Okay, QPU means the unit quantity resistance. This one is 120 kg per centimeter square. The unit end bearing resistance is 120 kg per centimeter square. It is the quantity resistance at the pile base, and that is equal to the unit end bearing resistance, which is 120 kg per centimeter square. If you know, if we convert this to the to kPa, then we will get 12,000 kilonewton per meter square. And I just and I also told in the last class, and just I also told just in the last slide, that it should be QPU should be less than 11,000 kPa, and this one is greater than 11,000 kPa. It is 12,000. So this should be always less than 11,000, right? 11,000 kPa. So this QPU we must consider 11,000 kPa. So okay. So I hope you have understood till now. So now next portion. This one is QPU. So now capital QPU, that is the total end bearing resistance. So QPU, okay, QPU. What is the capital QPU? That is the total end bearing resistance. It is AB into small QPU, AB into small QPU. What is AB? AB is the cross sectional area of the pile, of the base of the pile. So we know the diameter of the pile. Also, what is the diameter of the pile? Diameter of the pile is 40 centimeter, right? So that means pi by 4 into d square, 0.4 square into 11,000. So small QPU, it is that is the unit end bearing resistance. It is 11,000 kPa, and the area of cross sectional area of the base of the pile is pi by 4 into d square. D means 0.4. Okay, so if you calculate this, you will get the QPU will come out to be 1382 kilonewton. Okay, so QPU comes out to be 1382 kilonewton. Fine. Now we have been asked to find out the length of the pile. We don't know the length of the pile. We only know the safe load that the pile is carrying and the factor of safety. Okay, so so we know only the safe load that the pile is carrying and the factor of safety. Fine. So now let us consider the length of the pile to be L. let the length of the pile to be L. We don't know the length of the pile, right? So let us consider the length of the pile to be L, capital L. Okay. So we have found out the end bearing resistance, total end bearing resistance. Okay. So and the load carrying capacity of pile is equal to summation of total end bearing resistance and total skin friction. Okay. So now let us find out the skin friction. So that is, what is skin friction? QF, right? Capital QF, and capital QF is equal to Fs into As. Fs means the unit skin friction resistance, and As is the surface area of the pile. And now Fs. So we know the average value of cone-tip resistance along the length of the pile. Okay, so along the length of the pile, the cone resistance along the length of the pile, the cone-tip resistance, the average cone-tip resistance is 40 kg per centimeter square. Okay, so Fs will be equal to 40 kg per centimeter square. Now let us convert it to 40 kg per centimeter square. Mm, so now 40, so let me refer to a slide. Let me refer to a slide. Please wait for a minute. Yes. Okay. Uh, 1 minute. So see, this one is all right now here. So QF, that is the total skin friction resistance. It is a unit skin friction resistance multiplied by the surface area of the pile, right? So now Fs. Now here Fs is exactly not exactly 40 kg per centimeter square. I am explaining you why. So Fs. Uh, so using this QC, and the base is all right. For base QPU is 120 kg per centimeter square. There is nothing wrong. But for when we are finding out this Fs, that is the unit skin friction resistance, we need to consider certain things. Okay, so the average value of QC is 40 kg per centimeter square along the length of the pile. Okay, it is the cone-tip resistance, average cone-tip resistance along the length of the pile, which is 40 kg per centimeter square. Okay, now for displacement pile, it is also mentioned in the lecture that Fs, that is the unit skin friction resistance, is equal to QC by 2. Okay, this QC, average QC by 2, average QC is given. It is average QC. What is average QC? It is 40 kg per centimeter square. Okay, it is given in the question. It is given the average QC is 40 kg per centimeter square, and this, the unit of this is kg per centimeter square. This QC is in kg per centimeter square, but this one, After calculating what the value that you will get, it will be in kilonewton per meter square or kPa. Okay, so that means what is QC? QC is 40 kg per centimeter square by 2, and you will get 20 kPa, 20 kilonewton per meter square. This is an empirical equation. Okay, and you must not do this for the end bearing resistance, end bearing resistance. Okay, for unit end bearing resistance, QPU is uh, is equal to QC, actually QC, and the unit is also same. That is why I have transformed the unit from kg per centimeter square to kilonewton per meter square, but that is not the case for QF. Okay, please, while solving such sums, please mind this. Okay, for Fs, in case of skin friction resistance, Fs is equal to Qc, that is the average quantitative resistance, divided by 2, and the unit of this, and this Qc is in kg per centimeter square, and after calculating Qc by 2, the value that you will get, the unit of that value is in kilonewton per meter square. Okay, so that means the value of Fs is 20 kilonewton per meter square. I hope you have understood. So now let us calculate the value of QF. So what is QF? QF is equal to Fs into As. So Fs is equal to 20 kPa, that is 20 kilonewton per meter square. And so what is As? As is the surface area of the pile, right? So As is the surface area of the pile. So surface area of the pile means pi into d into L. So pi into diameter. What is the diameter of the pile? The diameter of the pile is 40 centimeter, right? So 0.4. So 0.4 into what is L? We don't know the value of L. We have considered the length of the pile to be L. So L. Okay. So, no, so this one is in kilonewton. So now if you solve this, you will get 25.12 kilonewton, right? So you know the safe load of the pile. The safe load of the pile is 650 kilonewton, and you also know the factor of safety of the pile, which is 2.5. So factor of safety is equal to 2.5, and QA, that is the safe load or the allowable load, it is 650 kilonewton. So QA is 650 kilonewton. So what is the ultimate load? So what is the ultimate load that the pile can carry? It is QA into F factor of safety, that is 650 multiplied by 2.5. This is the maximum load that the pile can carry. 650 multiplied by 2.5. This one comes out to be 1625 kilonewton. So 1625 kilonewton is the maximum load that this pile can carry. Okay. So now, so so this one is the maximum load that the pile can carry. Okay, QU. So you know the value of QU. You also know the end bearing resistance, total end bearing resistance, that is 1382, and the skin friction resistance, that is 25.12 L. Sorry, there will be L, this L. So we can say this QU, we can say, so the ultimate load or the load carrying capacity of the pile is equal to, we can say, the end bearing resistance, that is 1382. It is equal to 1382 plus the total skin friction resistance, that is 25.12 L. 25.12 L. We can write it like this. Okay, and this Q is also equal to this, that is 1625 kilonewton. So now let us equate both the things. Okay, so 1382 plus 25.12 L is equal to 1625 kilonewton. Okay, so now if you solve this equation, you will get the value of L to be 10 meter. Okay, so this is the answer. So I hope you have understood this problem. So I hope you have understood this problem. If you have any doubt, you may tell me now. Please let me know if you have any doubt in this question, or else I'll proceed to the next question. I am giving you 5 minutes. Please let me know if you have any doubts. Please let me know if you have any doubt. Hello. Okay. Third slide. So are you talking about this slide? So please let me know the doubt. I can't hear you actually. Please, please. Oh, this one is something is wrong over here. Please write your doubt in the chat box. Fs is the factor of safety. See, if you multiply the allowable load, okay, if you multiplied the allowable load, oh, this Fs is the unit skin friction resistance. See, see, this Fs is the unit skin friction resistance. Okay, this one, this Fs or this for questionless soil Fs. Fs is the unit skin friction resistance. Okay, so let me just tell you once again. Let me just explain you a bit. Hmm. See, in this question, it is a questionless soil, okay? And the static cone penetration test was conducted at the site. Here in the question, a static cone penetration test was conducted, and this QC is the average cone tip resistance along the length of the pile. It is given. It is 40 kg per centimeter square, okay? And this QC is the cone tip resistance at the base of the pile. That means the cone tip resistance of the soil over here, and this one is the average cone tip resistance of the soil over here. Okay, now this Fs, the value of Fs, that is the cone unit skin friction resistance. Now we know the average value of cone tip resistance along the length of the pile. It is 40 kg per centimeter square. And for displacement pile, for displacement piles, this Fs, that is the unit friction resistance, is equal to Qc, that is the average cone tip resistance divided by 2. Okay, we need to divide it by 2. So what was the unit of average cone tip resistance along the length of the pile? It is 40 kg per centimeter square. Okay, so Qc, we just need to put QC as it is. Okay, so it is 40 kg per centimeter square. It will be in kg per centimeter square, but the value that we will get after solving QC by 2, that is 40 by 220, the unit of that will be in kPa, that is kilonewton per meter square. Okay, so I hope you have understood. Please let me know if you have understood or not. Please write down in the chat box if you have understood or not. Somehow I can't hear you. Somehow I am unable to hear you. So please write down in the chat box if you have understood or not. Okay. So let me proceed to the next question. So please wait for 2 minutes. I will be back. Okay, so thanks for waiting. So this is the second question. So what is the question? A group of 9 piles arranged in a square pattern is to be proportionated in a deposit of medium clay. Assuming the pile to be circular pile with the diameter 500 millimeters, so diameter is given. Find out the required spacing for 100% efficiency of the pile group. Neglect the bearing or tip resistance of pile, assume adhesion factor of 0.8. So let me write down all the information that are given in the question. So diameter of the pile. So diameter of the pile is 500 millimeter. That is 0.5 meter. And here it is said that the pile group has 100% efficiency. Okay, I'll explain everything. So 100% efficiency. Eta means efficiency. Eta stands for efficiency, which is 100%. And adhesion factor, this adhesion factor is 0.8. So alpha is 0.8. Okay. So a group of 9 piles, okay, arranged in a square pattern. So 9 piles are arranged in a square pattern. So how will it be arranged in square pattern? So 3 piles in so like this, okay. Along the rows there will be 3 piles, and along the column there will be also 3 piles, okay, like this. 3 piles along the row and 3 piles along the columns. Okay, so 9 piles. In this way, the piles will be arranged in a square pattern, and the spacings are uniform. Obviously, it should be uniform for the group to be square. For this group to be square, all the spacings should be uniform. And okay, so now let me just solve the question. So let me just solve this question. So we know the diameter of each pile. Diameter is 0.5 meter. We don't know the spacing, and efficiency is 100%. So what is efficiency? So suppose what is the suppose Q is the ultimate load. Suppose Q is the load carrying capacity of a single pile. Okay. So there are 9 piles over here. So what ideally the load carrying capacity of all the 9 piles should be 9 Ku, because all the piles are similar. If the efficiency is 100%, then efficiency of the total of this pile group, the group of 9 piles should be 9 Qu, where Qu is equal to the load carrying capacity of a single pile. Okay, so this is so Qu is the load carrying capacity of a single pile, and if efficiency is 100%, then then the load carrying capacity of this whole group, that is the group of 9 piles, would be equal to 9 Ku. But that doesn't usually happen because efficiency is not equal to 100%. It is obviously less than that in real life situations. So the okay, so now in this particular question, the efficiency is 100%. So that means the efficiency of this total pile group would be equal to 9 Ku if Ku is the load carrying capacity of a single pile. Okay, so like this. Suppose this QUG is the load carrying capacity of this total pile group. It is equal to this efficiency, which is equal to 100% means 1, and QU single, okay, single pile. And here efficiency is 100%, that is 1. So that means QUG, huh, huh. So QUG is equal to the load carrying capacity of the pile group is equal to efficiency into multiplied by Qu, that is the single load carrying capacity of a single pile multiplied by the number of piles. Okay, so that is the efficiency is equal to 1. So that means QUG is equal to QU single into n is the number of piles. So number of piles is equal to 9. So that is 9. Okay, so it is 9 QU single, right? So now what is the load carrying capacity of the single pile? What is the load carrying capacity of a single pile? Okay, so here in the question it is mentioned, neglect the bearing or tip resistance. Okay, so end bearing resistance, here we have been asked to neglect the end bearing resistance. So that means we must consider only the skin friction. Okay, so that means Q single, that we must not consider the skin friction, so only the end bearing resistance. So we must consider only the skin friction, not the end bearing resistance. Okay, so that means Q single is equal to QF single. QF single, no end bearing resistance, no QPU. So QF single means ASFS. So what is as? uh, so what is as is the surface area of the pile. What is the surface area of the pile? It is pi into d into l. So pi into diameter. What is the diameter of the pile? Diameter of the pile is 0.5 meter. So pi into 0.5 meter into length. What is the length of the pile? Length of the pile is not given. Okay, so length of the pile is not given. Let us consider the length to be L. So pi d L is the area. And what is the unit resistance? Unit skin friction resistance. It is alpha into C, right? Unit skin friction resistance is alpha into C, or the alpha into C. Now, what is QUG? QUG is the load carrying capacity of the group. Okay, so load carrying capacity of the group. So suppose this is the spacing. Okay, suppose this is the spacing between two piles. Okay, so let us consider the spacing to be s. Okay, let us consider the spacing to be s. So what will be the length of this group? This length of this from the outer edge of the pile, from the from this outer edge to this outer edge, from the outer edge of this pile to the outer edge of this pile, from here to here. What will be the length? So this one is s, this one is also s, and this one is half of diameter, and this here it is also half of diameter. So that means s plus d by 2 plus d by 2. So that means if this is the diameter, see, let me draw it once again. We need to find out this length along this. Okay, and here there will be no space. Actually, here the circle should touch, this file should touch over here. So we need to find the this total length. We know this is the center to center spacing. This one is s, this one is also s, and this one is d by 2, and this one is also d by 2. Okay, so that means the length of this pile group, the length of this pile group, the length of a side is 2s plus d by 2 plus d by 2. Okay, so that means it is 2s plus d if d is the diameter of the pile. Okay, so this group is acting as a whole. Okay, so we need to, so that means we need to find, so QUG is also area of cross section multiplied by the unit skin friction resistance, that is AS into FS. So in case of this, while calculating QG, that is the group pile as a unit, we must consider the cross sectional, we must consider the surface area of this of the group. So what will be the surface area of the group? Surface area of the group. So for each side, if the length is L, for each side, it should be 2s in 2s plus d into L, right? It will be rectangular. So 2s plus d into L, and since there are four sides, the total area will be 2s plus d into L into 4. So area, that is AS, let me write it down like this. So AS. So there are four sides. So suppose this is a square and the square has four sides. Okay. So the area of each side. Okay. If the length of the pile is L and this length is 2s plus d. Okay. So length of each side will be 2s plus d into L. And since there are four sides, it will be, total area will be 4 into 2s plus d into L. Okay, and Fs, what, and here Fs is C. Okay, here Fs is average cohesion. Okay, here alpha is not needed. Okay, so now here it is said that, here in the question it is mentioned that the efficiency is 100%, right? So efficiency is 100%. So that means QUG is equal to 9 into QU single. Okay, So QUG is equal to 9 into QU single. Fine. So that means QUG. What is QUG? It is 4s plus d. What is d? D is 0.5 meter. So 4 into 2s. We don't know the spacing, center to center spacing, plus d. D is 0.5. 0.5. We also don't know the value of, we also don't know the value of L, that is the length of the pile. We also don't know the cohesion. Okay. So let me write it like this. So C is the cohesion and L is the length of the pile and S is the center to center spacing between two piles. Okay. And it is equal to 9 into QU single. So QU single is equal to this, pi into 0.5 into L, that is AS, 9 into pi into 0.5, pi into d into L, pi into d into L into alpha c. Alpha c, that is the Fs. Alpha c is the Fs. Okay. We know the value of alpha, right? So what is the value of alpha? Value of alpha is 0.8. Okay. This alpha is 0.8. Now let me just equate both the two terms. Okay. So let me just equate both the two terms. LL will get cancelled out. C will also get cancelled out, right? So that means here it is 4 into 2s plus 0.5 is equal to 9 into pi into 0.5 into alpha. Okay, alpha is there, so alpha is 0.8. So now if you solve this, here only one is unknown, that is spacing between two piles. Only this term is unknown. So if you solve this equation, you will get the value of S, and value of S will come out. If you solve this equation, it will come out to be 1163 millimeter. Okay, or 1.163 meter. Okay, so this is the answer. I hope you have understood this. If you have any doubt, please let me know in the chat box. Please let me know if you have any doubt in the chat box, or we may proceed to the next one. Please let me know. Please let me know. Oh, okay. Okay. So thank you. So let me proceed to the next question. So what is the next question? A solid floating pile of length 20 meter. So the length is given over here. Diameter is 0.5 meter. So a solid floating pile of length 20 meter and diameter of 0.5 meter is placed in a clay soil layer. The undrained cohesion of the soil is 70 kPa. The elastic modulus of the pile material is 20 into 10 to the power 6 kPa, and the elastic modulus of soil, the elastic modulus of pile material and soil is this and this. For soil, it is 55 MPa respectively. The adhesion factor value alpha is given. The Poisson's ratio of soil is also given. The proportion of load transferred to the pile tip, okay, is 2% or 0.02 after incorporating all the correction factors. The settlement factor I of the pile after incorporating of all the correction factors is 0.11. Based on the elastic analysis, determine the total amount of load the pile can take at the stage when the friction resistance is fully mobilized. So I hope you have watched all the lectures of week 9, but here, so in the lectures, elastic analysis is very well explained. Uh, and in this, you must know this elastic analysis to solve this problem. Okay, so what I will do is that I will brief the lecture here over here before solving this sum. I will just brief the concept. Okay, so let me just brief the concept once before solving this sum. Okay, let me just brief the concept once again so that you can understand it much more clearly. Suppose this is a load settlement curve. Let me suppose in this axis, in x-axis, it is settlement, and in this axis, it is load. So suppose you have a pile. Okay, suppose you have a pile and you are applying load on it. Okay, so what will happen? Suppose you have a pile and you are applying load on it, axial load. So what will happen? Initially, skin friction will get mobilized, right? Suppose you are applying load gradually on the top of the pile. So what will happen? Initially, the skin friction will get mobilized. Okay, the skin friction will start increasing up to a certain point, and then it will be constant. Okay, meanwhile, the end bearing resistance will also increase slowly. Okay, the end bearing resistance will also increase slowly meanwhile, and later on, when the skin friction gets completely mobilized, that means when the maximum value of skin friction is reached, after that the value of end bearing resistance will keep on increasing. Okay, it will keep on increasing, and after a certain point of time it will be constant, it will get constant. So let me just show you graphically what is actually happening. So initially, when you are gradually applying axial load on top of the pile, what is happening? All the load is being carried, is being, suppose you are applying load gradually on top of the pile. Initially, the load is being carried by the skin friction. Okay, so skin friction is increasing gradually as you are applying load on top of the pile. It is gradually increasing, and at a certain amount, after a certain point of time, after a certain load, it will get constant. Okay, the maximum, here the maximum skin friction is completely mobilized. Okay, and the maximum value of skin friction is reached. Fine. Meanwhile, as you are applying the load, meanwhile, what is happening is that as you are applying the load on top of the pile, the tip resistance is also getting mobilized. Okay, the tip resistance or the end bearing resistance is also increasing. The end bearing resistance is also increasing. And here at this point, all the skin friction is mobilized. Okay, that means the maximum value of skin friction is reached. So, but the end bearing resistance will still keep on increasing, and as you gradually apply the more load on top of the pile, this value of end bearing resistance will increase after a certain point of time up to here. Here at this point, the maximum value of end bearing resistance is achieved. Okay, so that means at this point of time, end bearing resistance is also maximum. Okay, so now if you just sum both this curve, you will get the total load settlement curve of the pile. So that means if you combine both the curve, you will get this type of curve. See, at this point, suppose this at this point py1 suppose this is the axial load that we are applying. So at this point of time, we are just combining both the curves, we are just adding both the curve. After adding both this curve and this curve, after adding, we will get this curve. Okay, so what is happening is that as you are applying the load, on top of the pile, this skin friction is increasing. Okay, this skin friction is increasing linearly, gradually. After a certain point of time, over here, okay, over here, this skin friction is completely mobilized. Okay, and meanwhile, this end bearing resistance is also increasing. And over here, when the axial load is at this point, see, this curve is the combination of both the curves. This one is the curve for end bearing resistance, this one is the curve for skin friction. If you combine both the curve, you will get the total uh, load carrying capacity, the total load settlement curve of the pile. Okay, so So at this point of time, end bearing resistance is completely mobilized, and the curve becomes flat. The curve becomes flat. Okay. So this is all it is. Okay. So I hope you have understood this. At this here, the skin friction is completely mobilized. Okay. So here it is P into ACU. Okay. Here the skin friction is completely mobilized, and this load here, this is the maximum end bearing resistance, where the end bearing is also completely mobilized. It is the ultimate end bearing resistance, and this is the ultimate pile load after combining both the resistance. That is the PU, that is the ultimate load that the pile can carry. It is the combination of both. It is summation of both the end bearing and the skin friction resistance. Okay, so this is the overall load settlement curve, and this one is the this one is the shaft load settlement curve, and this one is the base load settlement curve. So let me repeat it once again. This one is the shaft load settlement curve that is giving the skin friction. This one is the base load settlement curve, that is the end bearing part, and this one is the overall, that is the combination of both the curves. Okay. So now let us come back to the question. So let me just write down all the information given in the question. You can also visit, you can also refer to the lectures where the explanation of this graph is very well given. Okay, very well explained. So let me just write. So we have been asked, so here, we have been asked to determine the total amount of load the pile can take at the stage when friction resistance is fully mobilized. That means when the friction is fully mobilized. Okay, we need to find out the pile load at this point when the skin friction is completely mobilized. So what is the pile load at this point? This, the axial load that the pile was carrying when the friction was fully mobilized. So this, we need to find out py1, this one. At this point, skin friction was completely mobilized. Okay, and end bearing resistance was increasing. So that means corresponding to this point, this one is the combination, this one is summation of end bearing plus skin friction. This one is skin friction only, this one is only end bearing. This one is the summation of both. We need summation of both means the original load that the pile was carrying. So that means we need to, here we have been asked to determine the total amount of load. Total amount of load the pile can take at the stage when friction resistance is fully mobilized. That means this. Okay. At this point, the skin friction was completely mobilized. Okay. So that means we need to find Py1. Okay. So what is the maximum value of skin friction resistance? That is PSU. What is the value of PSU? That is the maximum value of skin friction resistance. It is AS into Fs. What is Fs? Fs is alpha C, right? So what is the surface area of the pile? We know the length of the pile, we know the diameter of the pile. That means it is pi into d into L. So pi into d into L. What is the length of the pile? It is 20 meter. 20 meter. And what is alpha? What is alpha of the pile? Addition is 0.6. Alpha is 0.6. Alpha is 0.6. And what is the value of C? The cohesion. What is the value of cohesion? The undrained cohesion of soil is 70 kPa. It is given over here, 70 kPa. Okay, so 70. This is the maximum skin friction resistance. Okay, so after calculating this, we will get the value of PSU. It is equal to 1320 kilonewton. Okay, now the portion of load transferred to the pile tip is 2%. Okay. Suppose you are applying a load of load P on the top of the pile. We are applying a load on top of the pile. Suppose we are applying a load of P on top of the pile. So 2% of that load is getting converted to uh, so 2% of that load is getting getting transferred through the pile tip to the base to the soil underneath the pile. Okay. So that means 2% of the load of 2% of P is getting transferred through the pile tip. Okay. So that means how much is getting transferred to the screen friction? So at this point, PSU is, we can write it like this. PSU is equal to, suppose PY1 is the current load that is acting on top of the pile. Okay. So PY1 is acting on top of the pile, and 2% of PY1 is getting transferred through the pile tip. Okay, so that means it is transferring to the end bearing resistance. Now, if we subtract that from PY1, if we subtract that load from PY1, we will get the load that is being transferred through the screen friction, right? So, can we write it like this? P beta into PY1 is equal to P into SU. P into SU is equal to 1 minus beta into Py1. Okay, so can we write it like this? See, 2% of Py1, if beta is equal to 2%, see, beta is equal to 2%. Okay, so the portion of load transferred to the pile tip is 2%. So 2% of Py1 is getting transferred through the pile tip. Okay, it is it is getting transferred through end bearing, right? So 2% of total load is getting transferred through end bearing. So how much is getting transferred through the screen friction? So total load minus beta Py1 is getting transferred through screen friction. And what is screen friction? Maximum screen friction is PSU. So we can write it like this, right? So we know the value of PSU. The value of PSU is 1320 kilonewton. So 1320 kilonewton is equal to 1 minus beta. So 1 minus 2%, that is 0.02. And how much is Py1? We don't know. We actually need to find that one. So we need to find out the total amount of load the pile can take at the stage when friction resistance is fully mobilized. Okay. So we need to find out this. Wait a minute. So this one, 1320 is equal to 1 minus 0.02 into Py1. We need to find out this. Okay. The Py1 is the total amount of load that the pile can take at the stage when the friction resistance is fully mobilized. Okay. Now, if you solve this, you will get the value of Py1. Py1 will be equal to, if you solve this equation, it will come out to be 1347 kilonewton. Please let me know if you have understood this sum or not. Please let me know. Please let me know if you have any problem in this sum. Please let me know if you have any doubt. Please write it down in the chat box. Do I need to explain that graph once again? Please let me know. It is very important. Okay, I will explain the graph once again. Please pay attention. See what is happening. Suppose you have a pile. Okay, let me draw it. Suppose you have a pile. Okay, you are applying load on it gradually. Okay, you are applying load on it gradually. So what will happen? Initially, the this load, suppose you are increasing this gradually, you are increasing the value of P gradually. So what will happen? Initially, this P, the value of P initially, as you increase this P gradually, what will happen? It will the this load will get carried out by skin friction. Okay, initially skin friction will increase. Skin friction will increase gradually. Fs, it will increase rapidly. Okay, it will increase rapidly, and this base resistance, that is the end bearing resistance, will also increase gradually. Okay, this one will increase rapidly, and this one, that is the qb, suppose qb will increase gradually. Qp will increase gradually. Okay, like this. Suppose this is the load settlement curve. Suppose this is the load settlement curve of this pile. Okay, so let me just divide this into two parts. One for this shaft, one for this shaft settlement. One curve will be for this shaft settlement, and another curve will be for this tip settlement. Okay, so initially what will happen? Initially, this skin friction will increase. This skin friction will increase rapidly as you increase this value of P. As you increase this value of P, initially the load will get carried by the skin friction. After a certain point of time, the skin friction will reach its maximum value. Okay, and it will get constant. Meanwhile, the quantum resistance will also increase. Okay, as you increase this value of P, the quantum resistance will also increase parallelly. Okay, initially it will increase very slowly, and after after that it will carry all the load, or that is maximum load. Some load is being carried by the skin friction, and maximum load is being carried by the end bearing. And after a certain point of time, when the maximum capacity is reached, end bearing resistance will also get constant. Okay, so this one is for shaft, low load settlement curve of the shaft, and this one is the load settlement curve of the tip. This one is shaft, this one is tip. Okay, now if you combine both these curves, okay, you will get the load settlement curve of the pile, of the overall pile. Okay, the load carrying capacity of pile is equal to the total skin friction, and also the total end bearing resistance. So that means if you combine both this curve, you will get the total load settlement curve of the pile, overall load settlement curve of the pile. So after combining, you will get something like this. It will increase like this. Here the skin friction is completely mobilized. After that it will be like this, and here the end bearing resistance is mobilized. Complete end bearing resistance is mobilized. That means here maximum end bearing value is reached. After that, it will flatten out. Okay. So at this point is the maximum skin friction resistance, and corresponding to this point, at this point, it is the pile load. Okay. At this pile load, maximum skin friction is reached. Okay. If the pile load is Py1, at Py1 maximum skin friction is reached, and this is the total value of skin friction and at this point this one is the value of the contive resistance. If you sum, if you add these two values, you will get the total load that the pile was carrying at this point. So Py1 is equal to PSU, that is the PSU, that is the skin friction, ultimate skin friction, plus this quantity value resistance. Okay, please let me know if you have understood this curve or not. Please let me know if you have understood this or not. Please let me know if you have understood or not. Please respond in the chat box. If you have any doubt, please. Okay, so you have understood. Fine. So now let us move to the next question. So what is the next question? The next question is also similar, but here we have been asked to determine the settlement of the pile at the stage when the friction resistance is fully mobilized. Okay, all the information is same, but here we have been asked to determine the settlement of the pile at the stage when the friction resistance is fully mobilized. So we need to find out the settlement at this point. So that means we need to find out the settlement when the pile load is Py1. Okay. So we need to find out the settlement when the pile load is Py1. Okay. At Py1 pile load, uh, the frictional resistance was fully mobilized. Okay. At Py1 pile load, frictional resistance was fully mobilized. So we need to find out the settlement at Py1 pile load. Okay. Determine the settlement of the pile at the stage when the frictional resistance is fully mobilized. Okay, fine. So there is a equation. So the equation is, you will find it in the lecture, obviously. So the equation is Py1, it is equal to I is the influence factor divided by Es into D. Es is the Young's modulus of the modulus of elasticity of this soil, and D is the diameter of the pile. PSU, we know what is PSU. It is the ultimate skin friction resistance, minus 1 minus beta. So now let us just put the parameters or the values of all the parameters into this equation. So I, what is I? I is the settlement factor of the pile. It is 0.11. So it is 0.11. Okay. What is ES? ES is the elastic modulus of the soil. It is 55 MPa. Okay. So 55 MPa means 55 into 10 to the power 3 kPa. Okay. 55 into 10 to the power 3 kPa. D, what is D? D is the diameter of the pile. Okay, what is the diameter of the pile? It is 0.5 meter. That is 0.5 meter. What is PSU? PSU we have found out. So PSU we have found out. PSU is this 1320 kilonewton. So PSU is 1320 kilonewton divided by 1 minus beta. What is beta? Beta is 0.02 or 2%. So 1 minus 0.02. So now if you solve this equation, you will get the settlement. Okay. You will get the settlement, and this one is not Py1, actually this one is del y1. That is the settlement. Del 1 is the settlement under Py1 load. Okay. So the pile load here, the pile load is Py1, and the settlement corresponding to a Py1 pile load is del y1. Okay. So del y1, after solving this equation, you will get the value of del y1. So del y1 comes out to be 5.4 millimeter. So this is the settlement of the pile. Okay, please let me know if you have any doubt. There is the equation. I have just incorporated the values of all the parameters into the equation and solved the equation. Okay, so this is a very simple sum. I hope you have understood this. Okay, so let me go to the next one. So here in this question, what is it? It is mentioned? A solid floating pile. Okay. Similar question. Here we have been asked to determine the ultimate load that the pile can carry. That is the QU. Determine the ultimate load that the pile can carry. That is the ultimate load. All the other information are same. So what is the ultimate load that the pile can carry? It is the summation of maximum skin friction resistance and the maximum end bearing resistance. So we need to just find out both the terms, and we need to just sum it up. Okay. So we need to find out the maximum skin friction resistance and maximum end bearing resistance. Okay. So we have already found out the maximum skin friction resistance. What is the maximum skin friction resistance? It is 1320 kilonewton, right? It is the maximum skin friction resistance. That is at this point. This is the maximum skin friction resistance. So PSU is how much? PSU is 1320 kilonewton. So PSU is, that is the maximum skin friction resistance or the ultimate skin friction resistance. It is 1320 kilonewton. Fine. Now you need to find out the maximum end bearing resistance. So what is the maximum end bearing resistance? That is P into BU, maximum end bearing resistance or the ultimate end bearing resistance. For clay soil, for it is actually QPU into AB, right? And for clay soil, it is NCAB equal to 9 into C into AB, right? So 9 into C, what is the value of cohesion? It is given. 100 cohesion of the soil is 70 kPa. So 9 into 70 into AB. What is the cross-sectional area of the cross-sectional area of the pile? If the diameter is 0.5 meter, then AB is pi by 4 into d square. That is 0.5 square. If you solve this, you will get the value of PBU, that is the end bearing resistance, total end bearing resistance. It will come out to be 124 kilonewton. Okay, so the ultimate load that the pile can carry, it is QU. Suppose if it is QU or PU, both are same. It is PSU plus PBU. PSU plus PBU. It is equal to 1320 plus 124. 1320 plus 124 kilonewton. So it will come out to be 1444 kilonewton. So this is the maximum load that the pile can carry. So please let me know if you have any doubt in this question. Okay, can you see the slide now? Uh, so have you understood this problem? Can you see the slide now? Please go through this problem once. Let me explain it once again. What I have done. Here we have been asked to find out the ultimate load that the pile can carry. The information is similar to that of the previous problems. We know the ultimate friction. So what is the ultimate load that the pile can carry? Ultimate load is equal to the total skin friction resistance and the total end bearing resistance, summation of both the terms. And total skin friction resistance, we have found out PSU in the earlier problem. It is 1320 kilonewton, like this. PSU is AS into FS. FS is alpha C. So it is 1320 kilonewton. and the frictional part is 1320 kilonewton, skin friction resistance, ultimate skin friction resistance, and ultimate end bearing resistance is 124 kilonewton. Okay, that is QPU into AB. It is equal to 9C into AB. It is the ultimate end bearing resistance. It is 9C into AB. If you calculate this, you will get it comes out to be 124 kilonewton. And if you just add both the terms, you will get the total end bearing resistance, which is 1444 kilonewton. So please let me know if you have understood this or not. It's not showing. Can you see the slide now? Wait a minute. Can you see the slide now? Please let me know if you can see the slide now. Please respond in the chat box if you can see the slide. And please let me know if you have understood this problem or not. Please respond in the chat box. Okay, so have you understood this problem? So have you understood what is happening over here? So you can't see the slide. So are you not able to see the slide? Okay. See what is happening. We have been asked to determine the ultimate load that the pile can carry. So what is the ultimate load? Ultimate load. So what is the ultimate load that the pile can carry? Ultimate load of the pile. It is the summation of maximum skin friction resistance and maximum end bearing resistance, right? So we need to find out the maximum end bearing resistance and ultimate skin friction, and we need to add both the terms. After adding both the terms, we will get the maximum pile load. Okay. So what is the maximum skin friction resistance? PSU. We have just found, we have determined this over here. PSU is equal to 1320. It is the maximum skin friction resistance, and this PBU, this is the maximum end bearing resistance. What is end bearing resistance? This is PBU. It is unit end bearing resistance into AB, that is the cross section of the base of the pipe. It is equal to NC into AB. NC in, and NC is equal to 9 into 9C. Bearing capacity, NC is the bearing capacity factor. It is equal to 9C. So QPBU 9 is equal to 9C into AB. We did similar type of problem earlier also. So if you just see what is the value of C, the value of C is 70 kPa. So if you just put all the values of all the parameters into this equation, you will get the value of PBU. See, value of C is 70 kPa, and what is AB? It is the cross sectional area of the pipe. So if the diameter is 0.5, the area of the base of the pile is pi by 4 into d square, that is 0.5 square. If you solve this, you will get the value of PBU, which is 124 kilonewton. And now if you just add both this term, that is the ultimate skin friction resistance and the ultimate end bearing, you will get the maximum ultimate load of the pile, which is the maximum load the pile can carry. Okay, so please let me know if you have understood. Please let me know if you have understood this problem or not. Okay, fine. So let me proceed to the next question. In the next question, the data, the information given is similar to that of the previous questions, but here we have been asked to determine the total settlement of the pile corresponding to the ultimate load. In the last question, we are asked to determine the ultimate load the pile can carry, and in the last to last question, we are asked to find out the settlement of the pile at the stage when the frictional resistance is fully mobilized. Okay, and here in this question, we have been asked to find out the total settlement of the pile corresponding to ultimate load. Let me just look at the graph. We need to find out this settlement. Okay, this settlement at the ultimate load. Okay, here this is the ultimate load that the pile can carry. Okay, this is the value of pu. So we need to find out this settlement. Okay, so we need to find out that settlement corresponding to pu. So for that there is a equation. So let me write down the equation. So del u is the settlement corresponding to the ultimate load. Okay, so del u is equal to I influence factor divided by es, that is the modulus of elasticity of soil into diameter of the pile into pbu, that is the ultimate end bearing resistance, divided by beta, that is the that is the portion of load transferred to the pile tip beta, plus pbu minus psu, that is the ultimate skin friction resistance, divided by 1 minus beta into beta into L by AP EP. Okay, so we know the value of I. I is the settlement factor. We know the value of ES. This is the value of this is the value of ES, the elasticity model, the elastic modulus of pile and soil. This is the elastic modulus of the pile, and this is the elastic modulus of soil. So we know the value of ES. We know the diameter of pile. This is the diameter of pile. PBU. What is PBU? It is the ultimate end bearing resistance. We have found out the value of PBU. It is 124 kilonewton. We know the value of beta. Beta is the portion of load transferred to pile tip. It is 2% or 0.02. PBU, we know we have already determined. We know the value of PSU. We have already determined the value of PSU over here. See, 1320 kilonewton. It is the ultimate skin friction resistance. We know the value of beta. We know the value of L, that is the length of the pile. It is 20 meter. We know the value of AP. AP is the surface area of the pile. Okay, it is pi into d into L. We know EP. EP is the Young's modulus, or the modulus of elasticity of the pile, which is this modulus of elasticity of pile material. Okay, so now let us just incorporate the values of all the parameters into this equation and solve it. So del u, that is the settlement corresponding to the ultimate load pu, is equal to I by ESD. Okay, so I, what is I? I is 0.11. What is the value of ES? It is 55 kPa, 55 MPa, that is 55 into 10 to the power 3 kPa. And D, what is the diameter of the pile? It is 0.5 D. Now this term, PBU by B. What is PBU? PBU is this 124 kilonewton. So 124 PBU is 124. The beta, what is beta? It is 0.02. Okay. Plus PB, what is PBU? It is 124. Plus, sorry, minus PSU. Okay. So what is PSU? PSU is the ultimate screen friction resistance. It is 1320 kilonewton divided by 1 minus beta. So 1 minus beta means 1 minus 0.02. 1 minus 0.02 into beta. How much is beta? Beta is 0.02. Okay. And this L by APEP. Okay. So what is L? Length of the pile is 20 meter, right? 20 meter. 20 APEP. What is AP? AP is the area of the base of the area of the pile, cross sectional area of the pile. So if diameter, no, sorry. So AP is the cross sectional area of the pile. AP is the cross sectional area of the pile. If the diameter is 0.5, that means AP will be pi by 4 into d square, that is 0.5 square into here EP. What is the value of EP? That is the Young's modulus of pile. It is 20 into 10 to the power 6 kPa. It is 20 into 10 to the power 6 kPa. So now if you solve this, you will get the value of settlement corresponding to the ultimate load. It will be equal to 25.3 mm. So please let me know if you have understood this problem or not. Please let me know in the chat box. We have just solved a simple equation after incorporating the values of all the parameters that we have determined. This is the equation. Please let me know if you have any doubt in this problem. Just go through the equation once and please let me know if you have any doubt. Please let me know if you have any doubt in this question, or else I will proceed to the next question. Okay. So now I will proceed to the next question. So the next question is, a group of 9 piles arranged in a square pattern. A group of 9 piles arranged in a square pattern in a deposit of sandy soil. Okay. The diameter and length of the circular pile is 500 millimeter and 15 meter respectively. This is the diameter of the pile. This is the length of the pile. The spacing between the piles is this 1.5 meter or 1500 millimeter. The settlement of a single pile under 200 kilonewton load is 6 mm. Determine the settlement of the pile group under the same average load per pile. Okay. Use Skempton 1953 correlation. So here is in the question, what it is said that a group of 9 piles arranged in a square pattern in a deposit of sandy soil. Okay. the diameter and length of the piles of the diameter and length of the pile is given. Either the diameter is 500 millimeter, the diameter and length of each pile. Okay, the diameter is 500 millimeter and length is 15 millimeter. The spacing between the piles is also given. The spacing is 1.5 meter, and the settlement of a single pile. Okay, if we consider a single pile, then the settlement of that single pile is 6 millimeter under 200 kilonewton load. Okay, so now we need to find out the settlement of the total pile group under same average load per pile. That is, under same average load means 200 kilonewton per pile. We need to use Kempton 1953 correlation. Okay, so before solving this sum, uh, let me write down the Kempton equation once. Kempton 1953 correlation. Okay, so suppose for same average load per pile, the settlement ratio of group of pile to the single pile. Okay, we have been asked to find out the settlement of the pile group. Suppose SG is the settlement of the pile group and SI is the settlement of a single pile. Okay, so Skempton has given a equation. Okay, SG is the settlement of the pile group, SI is the settlement of the single pile. So SG by SI is equal to 4 into B plus 2.7 divided by B plus 3.6 square. What is B? B is the width of the pile group. So B is the width of the pile group in meters. So that means in the question it is said that a group of 9 piles arranged in a square pattern. That means group of 9 piles like this. Diameter of the pile is given. Diameter of pile is 500 meter or 0.5 meter, and the spacing between the two piles is 1500 millimeter. That means 1.5 meter. Between these two piles is 1.5 meter, and the diameter of each pile is 0.5 meter. So what will be the width of this pile group up to this? So this is S, this one is S. So what will be the width of the pile group? It is 2S plus D by 2 plus D by 2, right? This one is B. So 2S means 2 into S. What is the value of S? The spacing between two piles, it is 1.5 meter. So 2 into 1.5 plus D by 2. What is the value of D, small d? It is 0.5 meter. The diameter is 0.5 meter. So d by 2 plus d by 2 means d. Okay, so that means 2 into 1.5 plus 0.5. Okay, so this one is the value of b. So if so 2 into 1.5 plus this one, um, d plus d by 2 plus d by 2 means d, and d is 0.5. So 2 into s means 2 into 1.5 plus 0.5. If you calculate this, you will get the value of b to be 3.5 meter. Okay, now let us just put this b equal to 3.5 into this equation. So sg by si is equal to, what is the equation? 4b plus 2.7 divided by b plus 3.6. Okay, so 4 into how much? 3.5 plus 2.7. We must note that the b should be in meters. Okay, it is an empirical equation and the b should be in meters. So b is how much? B is 3.5. So 4 into 3.5 plus 2.7 divided by b plus 3.6. So 3.5 plus 3.6. Okay, square. If you calculate this, you will get Sg by S1. It comes out to be 5. How much it is? It comes out to be 5.53. It is a ratio. Sg by S1 is a ratio. So Sg by S1 SGO SI is equal to 5.53. Okay. Now here in the question it is mentioned that the settlement of a single pile under 200 kilonewton load is 6 mm. The settlement of a single pile is given. It is 6 mm. Okay. So now if you just so now SG is equal to 5.53 into SI, and SI is how much? That is the settlement of a single pile. It is 6 millimeter. So that means SG, that is the settlement of the pile group, is equal to 5.53 into 6. And if you calculate this ASG comes out to be 33.2 millimeter. Okay. I hope you have understood this problem. If you have any doubt, please let me know in the chat box. Please let me know in the chat box if you have any doubt. Please let me know if you understood this question or not. If you please let me know if you understood this problem or not. If you have any doubt, please let me know in the chat box. Okay, so I believe you have understood this problem. So that is all for today. I will solve all the other rest of the problems in the next session. That is all for today. And so goodbye for today and good night. We'll meet again in the next session. Okay. So please follow all the questions. I hope you don't have any doubt. And so I hope you'll be able to solve the assignments very easily. So, okay. So thank you for attending to this session. Goodbye.